Okay, last time y'all talked about linear functions, and I asked you what was the root word. You said the root word was line. So you know that linear functions deal with lines, straight lines to be exact. But functions in general, those are just relations where every x value every x value has exactly one y value. We're on the last page. You see it? You see it last page. That's it. Linear functions, remember, talked about this last time, where functions, their graphs are going to be a straight line. Be specific. If I'm talking about a function, technically it would have to be a non-vertical line, because remember the vertical line test? If it's a vertical line, it would fail the vertical line test. So, in general, just looking at it, we can see if it passed the vertical line test. We can see if the x values repeat, but there's something else about linear functions. Linear functions are always going to have a constant rate of change. That is why we can do the rise over run, because it doesn't matter where you go on your graph. If you count up a certain number to the next placement and then do it again, it's always going to be the same thing. That is what we call a constant rate of change. However, if you notice prefix nonlinear, obviously that would mean not linear, right? Nonlinear functions do not have a constant rate of change. Meaning as your x values increase or decrease at the same value, the y values are not increasing or decreasing at the same value. Graphs of nonlinear functions are not straight lines. All right, so this is the simplest method, and you're going to love this on your quiz. Look at your graph. You're going to think, this is a duh moment, right? Looking at your graphs, which is this first one, linear or nonlinear? That's the easiest thing. If you missed out on the quiz, shame on you. What about the next one? Linear. Okay, so that's the easiest part. Let's get to what's more difficult. If I don't give you a graph, instead, if I give you a chart, if I give you a table, not so much fancy tables, but if I give you one, you can tell from a chart of values whether or not it is linear or nonlinear, just to see if they increase, that's the first word here, or decrease at a constant rate over equal or same intervals. Okay, so meaning have to be the same intervals of which the x value is increasing and the y value is increasing. And I'll show you what that means. If you were looking at this chart, I'm going to go from here, from top down, okay? From -2 to 1, I know it's kind of weird because it's negatives, but you're coming closer to 0. From -2 to 1 is an increase of 1. So that's going up 1. From -1 to 0 also increases 1. From 0 to 1 increases 1. All of those are constant, increasing at 1. But this means that whatever your interval is here, if it's increasing by 3, if it's increasing by 2, it has to be the same over the same interval. So from 7 to 5, it's not increasing, it's decreasing by, okay, what about from 5 to 3? Same thing, decreasing by 2. From 3 to 1, decreasing by 2. When you see that they are increasing or decreasing over the same intervals, that's going to make a constant rate of change. Constant rate of change being a linear function. Does that make sense? Okay. This should be pretty simple to look at, because this is just pretty much what's on the quiz, what we did last time. And then this part here, where you're having to look at a chart or a graph and tell me if it's linear or nonlinear. And then you also have to look at an equation to see that as well, but that's pretty easy, I think. So now look at the next one. I am going from 16 to 18. That's an increase of 2. But from 18 to 25, that's not increasing by 2. It's increasing by increasing by 7. And then this is also increasing by 7. So this means, first off, you can see right there, you're not increasing by the same rate. However, if you were doing the y's first, you might think that it was, because from negative 20 to negative 15, you're increasing by 5, and increasing by 5 again, and increasing by 5. But what throws us off is that it's not a constant rate of change if this is an increase by from 2 to 7, okay? So that means it's going to be nonlinear in some aspect. Last, yep, got to be the constant, same thing, equal, same intervals. Another way you could check to see if it's linear or nonlinear is to write an equation in slope-intercept form. Slope-intercept. Okay, now I'm going to ask you, what is slope-intercept? Y equals mx plus b. Notice you have a linear term, meaning the value of the x has an exponent of 1. That's a real big red flag. If you have an x variable and the value of the exponent is not 1, it's not linear. Because if you remember, exponents that are 2 are those types of graphs over there called quadratic functions. Quadratic function, you did that. Okay, so that means if you can put it in slope-intercept form, then that means it's a linear function. Tell me, can you put this in slope-intercept form? Which one? The first one on this side, 3y equals 2x plus 6.
Yeah.
How? Thank you. If you divide everything by 3, it's in slope-intercept form because it's y equals 2 over 3x plus 2, making it linear. What about the second one? It's not linear if you have an exponent of 2. So this right here makes it linear because it's not an exponent of 1. Yes, it's nonlinear. To be exact, it's quadratic to be exact. Yes. Super easy, right? Flip over, do the back.